3 students, 1 lab, and the incredible secrets of air. These are the alchemist's apprentices. My name is Peter Wathers, and in my day job as a chemist, I study the elements and how they make up everything around us. But today, I'm joined by 3 young apprentices, and we're going to be looking at the properties of the air. How much air is in this room? How much do you think all the air in this room would weigh? How many grams?
2,000 to 3,000.
2,000 to 3,000. Well, actually, it would weigh around 2 million grams. Whoa. Okay, and that's 2 tons, which is about the same weight as 2 cars. So that's quite a lot of air here, isn't there? Thankfully, air is not very dense, so we don't really feel it. But what gases make up that air around us? So do you know what gases are in the air?
Nitrogen.
Mainly nitrogen. What else?
A little bit of argon. Oxygen.
Oxygen is the second most abundant. Anything else? Any other gases?
Water vapour.
There's a bit of water vapour.
Carbon dioxide.
Carbon dioxide as well. That's the main components in the air. They certainly know a lot about air. Let's take a closer look at one of those gases they mentioned. Now, what do you know about carbon dioxide then? What can you tell me?
If you burn fossil fuels, carbon dioxide is produced.
That's right. Anything else that you know about carbon dioxide?
You breathe it out and trees breathe it in.
Yes. All good answers. Using my specially made balance, we are going to explore one of the properties of carbon dioxide, its density. We've got 2 buckets either side. And what's in the buckets?
Air.
Air. Oh, very good, yes. There's nothing other than air, just the air around us in there. Let's see what happens when we introduce a bucket of pure carbon dioxide gas. See if you can pour that into there. Look at that.
That's amazing.
So you've actually just poured invisible carbon dioxide from this bucket into that bucket there. The oxygen molecules in the air we breathe consist of 2 oxygen atoms. Carbon dioxide is made up of 2 oxygen atoms and a carbon atom, so it's heavier. This heavier gas tips the balance over. So we've seen some of the properties of carbon dioxide, and now we're going to see if we can actually make some carbon dioxide. Carbon dioxide can be made in many ways, even just by breathing out. For this experiment, we are going to make the gas from a rock called calcium carbonate. First, though, my apprentices need to earn their keep as we set about breaking up the rock. These experiments should never be carried out unless supervised in a proper laboratory. Do not try them at home. Inside our test tube, we've got our calcium carbonate rock. That contains calcium, carbon, and oxygen. And shortly, I'll be testing my apprentices to see if they know what it's made from. We're going to try and collect some of the carbon dioxide. We're going to force it out of the calcium carbonate, okay? And we want to see if we can trap it. Now, how do you think we can do that?
Liquid nitrogen.
We could use some liquid nitrogen, and that would cool it down and convert it into the solid form. Okay, so that's what we're going to do. Using freezing liquid nitrogen, we can cool down our carbon dioxide gas as it's produced. This will change its state into a solid and capture it in a test tube before it can escape. Now, we need pretty high temperatures for this, so I'm going to use 1,000 degrees C, this particular flame. So the calcium carbonate contains, well, which elements do you think it's got in it, calcium carbonate?
Calcium.
Calcium, yes, clearly. The
Carbon.
is in the name. Carbon, yes. And there's one other one.
Oxygen.
Oxygen, that's right. Now, I wonder if we're getting anything forming on this side. Well, we've got some white on the sides there. That could be some carbon dioxide. I think we'll stop heating this in a moment, and I'm going to attach a balloon to here in a minute, and then maybe when we remove this, as the CO2 turns back into the gas, it might blow up the balloon. We'll see. As we take away the freezing liquid nitrogen, the carbon dioxide quickly expands back to its gaseous state. This is quite normal, as carbon dioxide is a gas at room temperature. But there is something unusual happening. This is a little block of solid carbon dioxide, and all it's doing there is turning directly into carbon dioxide gas. That's quite cool. So it's not melting at all. And does anyone know what this is called when a solid goes directly to a gas?
Subliming.
Very good, yes, this is subliming. Sublimation is the name of the process when a substance changes from its solid state to its gaseous state without becoming a liquid. Because there's never any messy liquid, solid carbon dioxide is also known as dry ice. So that's the carbon dioxide produced in our experiment. But what about the calcium oxide left in the test tube? How has that changed? This started off just like the rock that you chipped away. That was calcium carbonate. We've heated this one up. It's cooled down again now, but it's changed. So it's no longer calcium carbonate. What is it?
Calcium oxide.
Calcium oxide. And I'm just going to put some water on this. So put some water on here. Well, what's going to happen? What do we get?
Wet rock.
Wet rock, OK. But if I give you the watering can, what I'd like you to do is just sprinkle a little bit on the rocks, both on the rocks there. And what have we got now?
Carbon dioxide?
No, it's not carbon dioxide. There's no carbon left in this. It was only calcium oxide. As the water reacts with the calcium oxide, it gives out heat in what's called an exothermic process. The heat turns some of the water to steam. And what's being made? It's a substance called calcium hydroxide, which when dissolved in water is called lime water. Lime water is used as a test for carbon dioxide. The early alchemists thought that the air was a single substance, but of course we now know it's a mixture of different gases. And if we cool these gases down, we can make first the liquids, and then at even lower temperatures, the solids. And these gases that make up the air have very different properties. We've seen the carbon dioxide is heavier than air, and we can form this by driving it out of some of the minerals around us, like the calcium carbonate. But yes, I was saying that the calcium oxide...